Why Sophia, teacher?
Oh, okay. All right. Okay, what I'll do is I'll join it as well. Okay. All right, teacher will try to speed up a bit, yeah? Okay, so yes, Umaira asked me a question, and Umaira said, teacher, electropositivity is the ability to donate electron. Yes, correct. Okay, electropositivity is the ability to donate electron. I'll share my screen one more time. Okay, so today teacher's going to teach. I'm not going to do any questions with you. Okay, because I think after I teach you today, you will understand the concept. Then if you want to start doing the paper I gave you, the past year paper, the trial papers, you can already start. Then only you can know, oh teacher, I think I know how to do. Oh teacher, I think it's quite difficult. Okay, so like if some of the 4A kids are already asking questions, they are trying the questions. So teacher think that once I finish teaching you today, you also can get the idea of how to answer them. So I mentioned that Wafia was my lithium, 2.1, my sodium 2.8.1, and potassium was 2.8.8.1. And if I'm able to donate my electron easily, I'm electropositive. And when I'm electropositive, more electropositive, I'm higher in reactivity. So let's say this is Wafia, right? Wafia was very close to teacher yesterday. And then her valence electron, her one wants to run away from me. I'm the nucleus. I can hold the one closer to me, and Wafia can't run away from me. So that's why that day when we did the reaction with lithium, the reaction, the reactivity was just normal, nothing great. Okay, because it cannot donate its electron very easily. But when I went to sodium 2.8.1, it became a bit more reactive. Sometimes we even say that sodium, sometimes the yellow flame or the hissing sound is actually stronger compared to potassium, but actually in theory it doesn't work that way. Okay, sodium, which was Suha that day. Okay, Suha is in the second row. So if Suha wants to donate her one electron here, she's able to donate that one electron. And am I still able to catch her? Yes, but not as easily as I can catch Wafia. So if Suha wants to donate the one electron, if Suha wants to run away from teacher, she could run away from teacher, but not as easily compared to um, if I want to hold Wafia. Okay, so sodium in that sense, because it still can donate this electron, I can't catch it very easily, either nucleus. So it is more electropositive, or you can say more reactive than lithium. However, you look at potassium. Potassium is Sharifa. She's sitting in the third row. She wants to run away from me also. I can't help her. Okay, I can't run after her. Imagine Sharifa is staying in London. Also, imagine Wafia is my daughter in school. And this daughter in school, I asked her, Wafia, you study, yeah? Make sure you sit down and study. Wafia got no choice. If I say sit in the lab every day, she has to sit in the lab. If she doesn't come to the lab, because I'm the mother, I can go and find for her, come to the lab. So Wafia cannot run away from me. Suha, let's say she finished from 5 already, she's in college. Okay. And then Suha, if I call her, Suha, what are you doing now? She can say, oh, mommy, I am studying. Padahal she's not even studying also. Okay. She may be talking to her friend or whatever, but I wouldn't know. But if I really want to know, I can actually take my car and drive to the college and find out, is Suha really studying or not? So in a way, I still can check on her, but she still got a way of to run away from me. So in the middle, Wafia cannot run away from me. Suha got a little bit of possibility to run away from me. But Sharifa, she's staying in London. Okay. She's all the way in London enjoying herself there. So let's say I'm the mom calling her. Okay. Sharifa, are you studying? Are you doing your work? Are you whatever? Oh, yes, yes, yes. I'm doing everything, mommy. I'm doing everything. Padahal not even one thing she's doing. And would I know? I wouldn't know. And can I go and check on her? I also cannot go and check on her. Sharifa, very lucky, yeah? Okay, because she's so far away from me. Okay, the distance of the valence electron here and the nucleus, which is in the middle here, is so far away. Therefore, Sharifah can run away. This one electron can donate its electron more easily. And I, the nucleus, cannot catch it. Okay, that's why it's more reactive. Do you all get that concept? Put in the chat what teacher just told you. Put in the
So,
chat.
so, so basically, lithium is reactive,
No, 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 no,
sodium
no.
is more,
Lithium is reactive. Sodium more
sodium
reactive.
is more reactive, and potassium is the most reactive.
Correct, that's right. Of course, when I go down the group, then rubidium, francium, and cesium are the most reactive lah. But for your level, I only teach you these three only.
Sure, what if they ask to explain that?
Why lah? So I'm going to that now. Okay, so I give you the analogy first. In exam, you cannot say Ponchina holding me, and then second row, third row, London college, or cannot. So what you need to remember is saya dah faham Okay, saya dah faham Okay, saya is size. Going down group 1, the size of the atom increase. You already agree. 2.1, 2.8.1, 2.8.8.1. Okay, you can see the size is increasing. If someone is chatting or someone is putting in the group, right? You or someone wants to come in or whatever, tell teacher because I can't see it from here. Ah, I think I know why. Yeah. Okay. If someone chats in the group or anything, the teacher does not realize it, or someone is waiting in the waiting room, let teacher know. Yeah. Okay. So when the size going down, okay, saya dah. The dah is distance. Okay. So the distance between the nucleus, copy teacher. This I don't like this particular sentence, so you copy my sentence. The distance between nucleus. Okay, Afam is trying to come in. Between nucleus and valence electron, okay, is further. Correct what? You notice me and Wafia closer, me and Suha not so near, me and Sharifa the furthest. So the distance between the nucleus and the valence electron is further going down group 1. Okay, when I talk about it being further, then the forces of attraction, okay, here they are missing the word forces. Okay, the forces of attraction between the nucleus and the valence electron becomes weaker. Force of attraction, you only can use two things. What is it? Teacher taught you that day. Force of attraction, you only can use two things. What are they? Very good. You only can use stronger or weaker. So when the valence electron is very far away from teacher, okay, my force of attraction becomes stronger or weaker? Me and Sharifa. Is my attraction between me and Sharifa stronger or weaker?
Weaker.
Very good. It is weaker. Okay. The rest of you, you can actually type the answer in the chat so teacher don't mind. Okay. So because the force of attraction becomes weaker, therefore E. Okay. So saya dah, here's forces of attraction, easier. Because it's so weak, so Sharifah can run away easily, right? So it's easier for the atom to donate the valence electron to achieve stable octet electron arrangement. That's why going down the group, the reactivity increases. Do you all understand that concept? So saya dah faham. Okay, I think you hang on. This boy wants to come in. All right. Okay, so do you all understand this concept? So would you like me to give you an example? Okay, so teacher's going to ask you now. Okay, before teacher asks you, can I have one person charge from his phone? Can I have one person here just taking a picture of this and putting it in the class group so everybody can refer to it when I'm teaching you shortly? Water in my lungs. Someone charge this? Sorry. Someone take a picture and put it in the group so everybody can refer to it. Okay. Done ready? Did anyone put it? Okay, thank you, Sachin. All right, now teacher's going to ask you a question. Compare the reactivity between potassium atom and sodium atom. This one is coming up for exam, eh? This is coming, I'm not sure whether I put potassium and sodium lah, but this topic is coming out for exam. And then if they give you specific, you must talk about it specifically. Okay, so what is the keyword? What did teacher teach you? How must memorize? What is the steps to memorize? What is the mnemonics I gave you?
Is it the saya dah faham age?
Very good. It is saya dah faham. Why teacher cannot hear the rest also giving teacher the answer? Can I also have everyone giving teacher the answer? You can type in the chat. If you don't type, then you will feel so sleepy, so bored. Very good. Saya dah faham. Very good. Okay. Saya dah faham. Okay. Now let's do line by line. So at least you know how to answer for exam. How to do line by line. So let's start with the S, size. Very good. So let's compare. How to write the first sentence. Teacher help you with the first sentence. Size of potassium atom is bigger than sodium atom. Now you look at Lakshan's answer. Lakshan said size of atom increases. So Lakshan will get 0 marks. Tak ada markah langsung. Because it's very general. And teacher doesn't want general answer. Okay, teacher wants an answer that is specific. Okay, so I must have the word size of potassium atoms. Everybody circle the word atom. Kalau tak ada perkataan atom, wrong. Must have the word atom. What is size of atom potassium? In cannot. You must compare potassium and sodium. Kalau dibagi comparison, you must compare. Okay, everybody try for teacher the DFE. All of you try for teacher now. Anis sudah masukkan the name list tak Anis? Oh yes, thank you Anis. Baru nampak. Okay, yang ni tak hadir Navia told me she can't make it. So yang tak hadir is actually Adrian, Hayden, Edward and Arifin. Anis, if you can put in another separate one. Navia, Haris.
Limal, right?
Just put
Navia,
there.
Harish, and Limal.
Iman ada. Navia, Harish, Rish.
Oh,
Yang
okay.
yang tiga ni dia dah beritahu cikgu awal-awal. Limal also, Limal.
Limal kan. Okay.
Okay. This 4. So 8 yang tak ada hari ni. Cukup tak? How many 31 students in the class kan?
Ya, cukup. Saya dah kira.
Okay. Thank you Anis. Banyak tolong cikgu. I'm so grateful. Thank you. Okay class. Who wants to do D? Can someone tell teacher also yeah, how to do D?
Me?
I think why that day teacher want to ask you all, yeah? Can someone help teacher that day? When I did with 4A, I could admit people from my phone. But for today, I can't admit. I think Hayden wants to come in, but I cannot admit him from my phone. Why? Anyone?
Sure, because your laptop and your phone is using the same. Is supposed to use the same account to control.
I should have learned this 3 years ago. During COVID time, never learned. Meaning to say that it's the same only what? I've got, don't worry lah. Just do it. Let's not waste time. He wants to come in. Okay, Hayden. Okay. Hopefully it's smoother now. Just Pranat, put in the group. If anybody else who wants to come in, just ask them to put in the group first. Because I wouldn't know. I will never know. Can you help me with that, Pranat?
Can, sir. Can,
Okay.
sir.
Thank you. All right. So I repeat. So the first one, saya, right? Okay. So potassium, the size of potassium atom is bigger than sodium atom. Okay, who can help teacher with the next one? Who wants to try saya dah? What is the sentence for dah?
Is the distance between nucleus and valence electron of K atom is further than Na atom?
Very good. Okay, excellent. The distance between nucleus and valence electron. Make sure your spelling for nucleus is correct. NECLUES. Okay, nucleus and valence electron. Okay, listen. For uh, a potassium atom is further than sodium atom. Okay, so this is correct. Okay, now many students, all right, when they want to write distance, they just say distance is further, but they don't say between nucleus and valence electron. So you lose your marks there already. You must have the word distance between nucleus and valence electron. Saya dah faham. Okay, who can try for teacher faham? Another person. Tak cuba, tak tahu, tak cuba. Tak cuba, tak tahu. Whatever. What is F? You can even type in the chat, no problem.
Can I try?
Yes, of course.
Okay. The force of attraction of potassium
Uh-huh. Oh, no, before that, the force of attraction between.
uh I don't know that part.
Okay, never mind. If
Teacher,
you,
I can try.
yes, go ahead. Actually, you're already there. Can we let Anis finish it or not? Because she's almost there. Suha, do
Okay,
you mind?
teacher.
Okay.
Yeah, no problem.
Ya, ikut yang atas ni je, Anis. Forces of attraction, follow. Between Anis?
Yes, sir. Yes.
You can use the same thing. Forces of attraction between, salin balik yang atas tu.
Oh, okay.
You want to say it?
Can.
Okay, say it.
Force of attraction between nucleus and valence for for potassium atom is stronger than sodium atom.
Correct or not? Is potassium atom so stronger ke weaker?
Weaker.
Potassium kan lagi jauh.
Oh,
Potassium is Sharifah. Sharifah lagi jauh dari cikgu. Kalau lagi jauh dari cikgu, cikgu tak dapat pegang dia dengan kuat. So it's weaker. Tapi
okay.
I like your sikap mencuba. Very good.
Okay.
Okay? Good job. Forces of attraction between nucleus and valence electron. Okay, she missed out the word electron. So maybe I'm going to write in full. So y'all can see clearly. Okay, FOA, y'all cannot write FOA in exam. Cannot. Only teacher can write. Okay? For the force of attraction between nucleus and valence electron of, you want to say off for second, for second, of potassium atom is weaker than sodium atom. Okay? So saya dah faham Okay, we're still doing potassium atom. Who wants to try potassium atom? The E. You can type. Teacher got no issue. You can type.
I forgot what's E.
E is easier. And that's why teacher asked you to snapshot and put in the class group. So you can refer to it when you're answering this question. It is easier for which atom to donate electron?
It's easier for. It's okay. I know. That's someone.
Cannot be sodium. When it's, you see, Sharifah kan? Sharifah is further away from teacher. If Sharifah is further away from teacher, my force of attraction between Sharifah and me as I'm the nucleus, she's my valence electron, our force of attraction is very weak. So when my force of attraction is very weak, I don't hold her very strongly. So she can donate her electron more easily. So the further you are from me, my force of attraction is weak. And when my force of attraction is weak, therefore you can donate electron more easily. So which one can donate the electron more easily? Potassium atom or sodium atom?
Potassium.
Very good.
Potassium.
It is potassium atom. Very good. So the sentence is, it is easier for potassium atom to donate its valence electron to achieve SOE A. What is SOE A, class? What did teacher teach?
Stable octet.
Stable octet, some more? Electron.
Arrangement.
Arrangement.
Very good. Electron arrangement. Okay. So in exam also, you cannot write SOE. Only teacher can write SOE because I am wanting to be quick. So it's easier for potassium atom to donate its valence electron to achieve SOE compared to sodium atom. Okay, teacher want you to take note. For every sentence, you notice I compared potassium atom to sodium atom. Every line, I compared potassium atom to sodium atom for every line. Okay, you must remember in a question when they ask you to compare, every line you must compare. And you notice another thing teacher did after every potassium or sodium, I put the word atom. Okay, if you don't put the word atom, you will lose that mark. Okay, so I hope that you understand this one. I can guarantee you this one is coming out for exam. So teacher put lah kat sini important. Okay, so you want to take a picture, you want to snapshot, you want to keep it for yourself, it's up to you. Teacher let you take a picture now. So this is a perfect marking scheme. Okay, if the question say, so the question is asking which is more reactive. So I already gave saya dah faham but I never say which one is more reactive. So class, you tell teacher here, which one is more reactive?
I think it's
Actually must be
potassium.
very good. Actually must be at the bottom tapi I got no ruang here. So teacher bring it on top. Okay, so potassium is more reactive. Notice tak cikgu tak tulis atom kat sini? Because now, no need to write atom. Tapi kalau you rasa, if you feel teacher, I'm very not confident lah, I want to put atom, you just put. It's okay. Okay, so potassium atom is more reactive than sodium atom. Perfect. Full 5 marks you get here. 5. Ngam. You need to write. You need to write so. You cannot write so here. You must write full word. Okay, so perfect. Yeah, teacher finished already this one. 5 marks. I hope you've taken your photos and all that you need. Okay, now, if you notice that day when we did the experiment, some of you asked me, teacher, why you put inside that water that I'm holding? Why no reaction? Because teacher that day put it in paraffin oil. It's not in water. Okay, I must keep it in paraffin oil because if I don't keep it in paraffin oil, it will get oxidized straight away. And of course, that day I told you you cannot touch it with your own hands. You must use forceps. You actually need to wear goggles and gloves actually. Okay, and you only must use a small amount of alkaline metal. Cannot use a big amount. If you look at the video teacher sent you, the one that used a big amount, they put into the lake, kaboom, the lake had explosion happening. Okay, so group 1 we settled already. Can I go to group 17?
Yes, can teacher.
Okay, teacher going to go faster already now. Okay, group 17 is fluorine, chlorine, bromine, iodine, astatine. Find some fat clown broke into the attic. Okay, fluorine, chlorine, bromine, iodine, astatine. Okay, a fat clown broke into the attic. Okay, what is F?
Fluorine.
Very
Fat.
good. Not fat lah. My goodness, exam jahat lah
Chlorine.
kau tulis fat.
Chlorine.
What is clown?
Chlorine.
Chlorine.
What is broke?
Bromine.
Bromine.
Bromine. What is into?
Iodine.
Iodine.
Iodine, and ethic will be astatine. They are all known as halogens and they are all diatomic, meaning to say, right? Okay, like I told you, group 18, they are all monoatomic gases, right? Monoatomic gases means what?
One.
Correct. Very good, Daniel. Okay, they are one. Okay, meaning to say helium, heat, He. No such thing as He2. Kepala otak engkau. Don't call me your chemistry teacher like that. Okay, but in group 17, it's not like that. In group 17, everything has a die is 2. So F2. Then chlorine Cl2. Bromine Br2. Iodine I2. Astatine AT2. All of them are diatomic molecules.
That biscuit that was full already, that but three only.
It's inside the packet.
Yes.
All right. Okay, so they are diatomic molecules and they are poisonous. Okay, I'm not sure if I told you before when I was in Cebu last time. The bromine vapor touched my hand. My hand decolorized, one finger, not hand, my finger decolorized. Okay, and I had to go to hospital for that. Okay, and then recently also teacher terkena chlorine, the gas. So please be careful. Our health is very important. Okay, I'll go now to physical properties. Okay, of group 17. Okay, someone said something. Sometimes if I miss something in the message, you tell teacher. Yeah,
Lakshan
teacher,
asked
can
to
you?
repeat again.
What do you want me to repeat? Repeat what, darling?
No idea. Monoatomic. You say monoatomic. Monoatomic not here lah.
Monoatomic is one atom. Diatomic, two atoms. Group 18, everything monoatomic. Group 18, yeah. Group 17, everything diatomic. Lakshan, you got that, Lakshan? All right, okay. Group 17, very important to know that they are very low and melting and boiling point. Okay, group 17, they exist as diatomic molecule. Okay, they exist as diatomic molecule, and then the color is very important. Okay, fluorine and chlorine, the color is pale yellow, chlorine greenish yellow, bromine reddish brown, iodine is purplish black. And then what is the state? Fluorine is gas, chlorine is gas, bromine is liquid, and iodine is a solid. Okay, so very, very important. They like to ask, chlorine exists as what color? You need to know. Bromine, what color? Normally bromine, I don't even put the word reddish. Brown is enough. And you need to know, bromine is a liquid. Chlorine is a gas. Iodine is a solid. Okay, y'all don't worry. Teacher will send this slide into your chat group later. Okay? So you can actually have a look at it. Okay, teacher's going to test you. What is the color of iodine?
Purplish black.
Purplish black, correct? Okay. What is the
Blue black.
Oh, where got blue black? This is not bio, okay? Not blue black. It's purple. It's purplish black. What's the state for chlorine? State.
Greenish yellow.
Greenish yellow.
Yes.
Yellowish green gas. Okay, it's a gas, correct? Later, teacher will test you all on the color of the real chlorine. Yeah. Okay. What is the state and color for bromine?
Liquid.
Okay, it's brown, correct. Okay, so it's a brown liquid. Okay, teacher just wanted to go back to iodine. To group 1. Group 1, did I tell you about the melting and boiling point? Do you all remember teacher telling you group 1, the melting and boiling point? Okay. Did I tell you about the melting and boiling point about group 1? Okay, in group 1, I told you in group 18, the melting and boiling point becomes bigger, correct or not? The melting and boiling point will increase. Did I ask 2 students to come to the front and then teacher compared the size and then teacher asked someone to break the bond? Did I do that with you?
Yes, teacher.
Yes, correct. Okay. So that one was for group 18. The smaller the size, the weaker the forces of attraction, the bigger the size, the stronger the force of attraction. So I need more heat energy. But I'm doing group one. In group one is a bit different. In group one, teacher got metallic bond because all metals. In group one, when I go down the group, yes, the size will increase, the size become bigger, but my force of attraction is weaker. So that means when you're going down group one, okay, uh, my metallic bond becomes weaker. So lithium and lithium, the metallic bond is stronger. Sodium and sodium, my metallic bond is stronger. But potassium and potassium, my metallic bond is not so strong. So my force of attraction is weaker. If my force of attraction is weaker, do I need a lot of energy or do I need a lesser energy to
Lesser
overcome?
energy.
Very good. I need lesser energy to overcome the forces of attraction. So remember, in group 18, when you go down the group, the melting and boiling point is increasing. Okay. But in group 1, when you're going down the group, okay, the melting and the boiling point is decreasing. Okay, it is decreasing. Why is it decreasing? What was the keyword teacher told you? Because my metallic bond becomes weaker. Okay, what is in exam? Teacher, I cannot remember the word metallic bond. It's okay. Can you see they also never write metallic bond? They put here the forces of attraction between the atoms. Between the atoms must have. If you don't write the word between the atoms, cannot. Okay, so going down the group, the metallic bond or the forces of attraction between the atoms becomes weaker. So teacher need less heat energy. I must have the word heat and energy. Okay, less heat energy is needed to overcome the forces of attraction. Can, can you get what teacher is saying?
Yes, sure.
Okay, this is group one. This is group one. Okay, now teacher go to group. I go to group 18. Okay, group 18. In a short while, I will ask you. Okay, they tell me here I've got low melting and boiling point. But tell teacher, when I'm going down group 17, what do you think will happen to my melting and boiling point? Will my melting and my boiling point increase? Going down, very good. Lakshan says increase. Okay, my melting and my boiling point will increase. Why? Why my melting and my boiling point is increasing? It's the same as group 18. It's the same thing as group 18. What did we remember about group 18? Why the melting and the boiling point for? You don't know. How come you say you don't know? Teacher taught you already. Okay, Lakshan don't know. How about the rest? So it's the same thing when teacher called two different boy sets to the front. The first one was the smaller size boy, and the second one was the bigger size boy. So when we are going down group 17, is the size increasing or is the size decreasing?
Increasing.
Increasing.
Very good. Okay, so going down group 17, the size is increasing. When the size is increasing, what happens to my forces of attraction between the molecules?
They
Becomes
become
closer.
stronger.
Very good,
Weaker.
become stronger. That day, who was the two boys? Who are the two thin boys? Haris and
I think it was Harish and Limal. Wait.
okay,
Harish and Farid.
okay,
Yeah,
Harish
Farrell.
and Faril. Okay, so these two boys, they're very thin. Okay, so it's easy for me to overcome then their force of attraction is very weak. Okay, easy for us to overcome the forces of attraction. Who was the bigger boys, teacher?
Our teacher
Uh,
was me.
sorry, who was the bigger boys? Hari and Adrian. Okay, so this is Hari and this is Adrian. Sorry, I hope you can see that I'm drawing them bigger. Okay, now the force of attraction between the both of them is stronger. Okay, and let's say Edward is coming. Okay, if Edward is the one that is going to break the bond, okay, or Arifin, whoever it is, okay, more heat energy I need to overcome the forces of attraction. Okay, so when forces of attraction is stronger, I need more heat energy. Okay, to overcome the forces of attraction. Can you get this concept?
Yes, sir.
Okay, the smaller the size, the smaller the size, the weaker the forces of attraction. The bigger the size, the stronger the forces of attraction. This applies for group 17 and this applies for group 18. Okay, must remember that. Okay, now in group 1, teacher told you we react with cow. In group 17, we are going to react with wish. Okay, so everybody, can you tell teacher what is wish? What do you think W is?
Water.
Very good. W is water. What do you think I is?
Iodine.
Iodine.
Not iodine.
Ion.
Iron. Very good. Iron.
Iron.
Okay. SH is not my name, not Sheena. Okay. But it's two names. What do you think
Sulfur and
it is?
hydrogen.
No, 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 no.
Okay.
It is actually one whole compound, a whole chemical, but it's starting with S, one starting with S, one starting with H. So it's actually sodium
So
hydroxide. Okay, sodium hydroxide. Okay, so now teacher see group 17 reacting with water first. Okay, so I take for example chlorine. Everybody write together with teacher chlorine. All of y'all writing chlorine. Teacher going to get to act with water, react with water. When chlorine react with water, teacher's going to get HCl plus HOCl. Okay, this one you must know because it's very important. You want to see mommy's student? Come.
Yeah, I can see.
You can. Come nearer here. Say hello, everybody.
Hello, everybody. But how they can see us when we cannot see them?
They all want to show us their faces.
Where is that?
Okay, now mommy continue teaching you. Listen first, okay?
Okay.
All right. So here we have chlorine reacting with water. We're going to get HCl. What's the name of HCl? Okay, what's the name of HCl?
Hydrogen chloride.
Hydrochloric acid.
Very good. It's
Chloride.
hydrochloric acid. Now, the other one is very important, HOCl. What is HOCl? It's actually hypochlorous acid. Teacher, why is hypochlorous acid so important? You know your bleach? Okay, in your bleach, we have hypochlorous acid, HOCl. And this one is a K-BAT question. Okay, this is a K-BAT question. They can ask you, what do we put in bleach? And if you don't know it's HOCl, then it's wrong. Okay, then you cannot answer. So
Can we just put HOCl if they ask any question?
if they didn't ask to name, you can put HOCl. If they ask to name, then you must put hypochlorous acid. Okay. Now it works for chlorine. It also actually works for bromine. Okay. Now HCl and HOCl, I hope all of you know, these are acidic. Okay. If they are acidic, if teacher put that blue litmus paper, what happened to the blue litmus paper?
Turn red.
Very good. Okay, my blue litmus paper will become red. Okay, so remember this one. Now, I want all of you to quickly try with teacher. Okay, bromine. All of us do together Br2 plus water. Br2 plus water. What do you think teacher will get? Similar only, chemistry like copy paste only. Whatever you see happening for one, very good. HBr plus
HOBR.
HOBR. Perfect. What's the name of HBr? Very similar to hydrochloric. Cannot be hydrobromide. Nah?
Hydrobromine.
Hydrobromic. Hydrobromic acid. And how about HOBr? Very similar to on top. Hypo. Hypo. No. Here you're ending with chlorus. So here must be
Bromide.
very good. Bromous acid. Okay, hyperbromous acid. My writing is amazing. I know it, don't have to mention. Okay, amazing writing teacher has here. Okay, next. Okay, hypochlorous, hydrochloric acid. Okay, so teacher done with you water already just now. Okay, WISH, right? I done with you water. Okay, now teacher want to do with iron. Okay, so chlorine can react with iron to form iron 3 halides. All of you try together with teacher. Now we take Fe plus with Cl2. Okay, all of you, give me the answer now. You should be giving me the correct answer because I've taught you how to darab silang. Now,
And okay.
some of you must speak louder. Teacher cannot hear you. We are going to get Fe3 plus, not Fe2 plus, okay? Your product must be Fe3 plus. Okay, halogen. This is a halogen. Okay, so Myra asked what is a halogen? Halogen is Cl2, F2, Cl2, Br2, I2. This is a halogen. A halide is F minus, Cl minus, Br minus, I minus. That is a halide. All this here is called a halide. Halide. Yes, a halogen is diatomic. HOCl, hypochlorous. Okay, I go back a bit. HOCl, hypochlorous. If teacher is too fast, you must tell. Teacher don't know. Okay, if I'm going too fast, you want me to repeat again, you want me to explain something, you just tell or type it in the chat. Speak up. Teacher can explain. If teacher's going too fast, also you can tell. Teacher haven't reached the place where I can telepathy, I can know what you're thinking. Especially when I cannot see you. I don't know what you're doing behind them. Okay, so try to tell teacher. Okay, okay. I saw somebody giving me the answer. FeCl3 says Arshi. I forgot lah. Who is quote again?
Sure.
Adam. Okay. Adam say FeCl2 3. Okay, salah. Okay. So the answer is actually here I've got Fe3 plus and here I got Cl minus. When I got Fe3 plus and I got Cl minus, when teacher darab silang, what am I going to get?
FeCl3, right?
Very good. You get FeCl3. Who's that?
Daniel je.
Okay, Daniel. All right. Long time no see, Daniel.
My bad, teacher, my bad.
All right. Are you feeling better now?
Yeah, teacher. Better.
Okay. So you get FeCl3. Anybody who doesn't understand this, teacher, how on earth you got FeCl3? Anybody?
Sure, you didn't use the 2 as the CL.
So I haven't balanced it yet. If you want, we must balance it now. Okay? Here teacher got 3 Cl. Here teacher got 2 Cl.
Yeah.
How to make the 3 and the 2 balance? Can I make it 6?
Yeah, teacher, make it 6.
Correct. So here teacher put 3 in front. Here teacher put 2 in front. Okay, perfect. Very good. Okay, and then my Fe also teacher must put 2. Okay, perfect. My answer is already correct. Okay, so we double check and see. Did we get the correct answer as the one given? Okay, yes. Here they use bromine lah, but teacher use chlorine. But it means the same thing. Okay, it means the same thing. We are going to get, see, the concept is the same. Now, what color is FeCl3? What color is FeBr3? What color?
Brown.
The answer is in front of you.
Brown.
Okay, the answer is brown. Okay, I want everybody to draw with teacher what I'm drawing. I'm drawing a tree, and I'm drawing the tree with the broccoli part of the tree. Okay, the leaves lah, so-called the leaves lah. Okay, I want you to write down here Fe2 plus, Fe2 plus, and I want you to write down here Fe3 plus. Okay, what color are the leaves?
Green.
Green.
Very good. So therefore, Fe2 plus is green in color. What color is the trunk?
Brown.
Brown.
So therefore, Fe3 plus is brown. Next time I will draw for you apple and all, then I'll give you different kind of color ion to remember. But for now, just remember these two. So whenever you see Fe3 plus, you must know it's brown in color. If you see Fe2 plus, it is green in color. Okay? This page you can understand. Teacher can go on to the next page.
Yes.
Okay, good. So I've told you already that group 17 reacts with wish. So I've done with you water. I've done with you iron. Now I want to do with you sodium hydroxide. So teacher's going to take a chlorine or iodine or a bromine, and I am going to react with a sodium hydroxide. Okay? Teacher's going to get three results. One is NaCl, one is NaOCl, one is H2O. Okay, and it's not balanced because here teacher got 2 Na, but here only 1. So teacher's going to put a 2 in front here. And that's it. Okay, that is the name of my product. So here they say sodium halide. The halide is because, just now remember Umaira asked, teacher, how you know it's a halide? Okay, normally halide is Cl minus, and betul kan here, my Cl is Cl minus. So this is a sodium chloride. Okay, a sodium chloride. Here is my sodium chlorate. Remember, teacher made you all memorize OCl minus, or in the paper I gave as a test got ClO minus, chlorate, BRO minus, bromate. Okay, so this is the chlorate, and then my side product is water. But sodium hydroxide not so famous in exam, not so important. Okay, so this is an example. Sodium iodide, sodium iodate, and water. Okay, now let's see. When we go down group 17, what do you think is happening to my size of my atom? 2.7, 2.8.7, 2.8.18.7. What is happening to the size here?
Getting bigger.
Very good. Okay, the size is getting bigger. Okay, very good. So why is the size getting bigger? Anyone?
Because there's more number of electron shells.
Okay, so Daniel said more number of electron shells. The concept is there, but the marking scheme answer is wrong.
Sure.
Those of you who came to
said you're going too fast.
Umaira says I'm going too fast. Okay, Umaira, which part fast, Umaira? From the slide before this slide? Does everybody agree with Umaira I'm going fast? So dia, but teacher got, oh, this part. Umaira, tak apa. Yang ni kan Umaira, jarang keluar exam. Kalau if I go fast in something like super duper fast, maksudnya dia tak penting. Macam tadi bila cikgu ajar yang saya dah faham 10 kali cikgu sebut kan, that means it's important. Okay, if something I say 1,000,000 times, that one is important. If something I go like super duper Superman speed, that means you know it's not important. If the thing that Adam asked why not 2.8.8.7, because That one there, we already have transition element ready. Someone's not muted. Pranat, I think, sorry, Pranat. Okay. So we don't have already 2.8.8.7, don't have. Okay, so this one is fluorine, chlorine. When it comes to bromine, is already bigger number already. But anyway, they never ask you this, so you don't have to worry about this. Just important for you to know that they end with 7, that's all. Okay, so never come out for exam. So when going down group 17, okay, size becomes bigger. Daniel says because the electron shells increases. But those of you who came to school that day, I gave you a keyword. What is the keyword? You cannot say electron shells. What is it?
Stable.
Outermost shell.
No, nothing to do with
Electron
stable.
valence.
Not valence.
Sir,
Yeah, I know.
outermost shell, right?
No,
Number of electrons.
wrong.
Number
Number
of
of
shells filled with
number
Proton
of
number.
electrons of the outermost cell.
No. I think someone was trying to say it, but then too many people were saying the same thing.
teacher, the the number of shells filled with electrons.
Correct, Adam. Okay, the number of shells filled with electron, because I told you what, here I got 2 shells, here I got 3 shells, here I got 4 shells. That's why my size becoming bigger. Okay, when you were a young child, you were this size. Then you come to standard 3, you're this size. Then you come to form 1, you're bigger size or bigger, taller. Okay, so when your number of shells filled with electron increases, your size also will increase. So what was the keyword that most of you did not get? Is you say the number of shells correct, but you must say occupied, or another word would be filled with electron. Then it's correct. Okay, the keyword is number of shells filled with electron. Okay, now group 17, I told you already, when you go down the group, the size become bigger, so my force of attraction becomes stronger, so more heat energy is needed to overcome the forces of attraction. So this one is the same like group 18, same concept. How to remember? You remember SFM. The size becomes bigger, okay, your forces of attraction become stronger, and therefore more heat energy is needed. All of y'all write down SFM. Okay, size, force of attraction, and more heat energy. It applies for group 18, it applies for group 17. Got it? Thumbs up, or you can type number 1 in the chat if you understand what teacher is saying. Type 1. Type 1, type 1. Teacher never asked you to put thumbs up. When I see your type 8, Pranat says 2. Pranat, why Pranat? Pranat, why you type 2? And Lakshan,
Teacher,
why? Yeah.
I wrongly put. Then after I corrected it.
Okay. Anis, oh, yeah, FOA is forces of attraction. Thank you, Anis. All right. So, yeah, whenever you see me writing short form, is because sometimes not enough time. Okay. Now, in group 1, we know that the reactivity increases. But in group 17, it's the other way around. Is my reactivity is decreasing. Filled with you're talking about this ke, Omaira? So when the size increase is because the number of shells filled with electron increases. Is this what you're asking for, Omaira? Okay, I'll wait for her to. Oh, okay, got it. All right. So she's understood. Okay. Now in group 17, okay, in group 1 tadi, how do I know something is more reactive? If I'm able to donate my electron easily, correct or not?
Yes.
All of you agree? Correct. Okay. In group 17, you ada 2.7, 2.87, 2.8.18.7. Takkan you nak donate 7 elektron? It's impossible. So you tak nak donate 7 elektron. How to become stable? Tadi if for group 1, 2.1, 2.8.1, 2.8.8.1, you nak jadi stable by becoming 2.8, 2.8.8. That's why you donate 1. For this one, how to become stable?
Receive electron.
Very good. I want to receive electron and I will receive 1 electron here, 1 electron here, 1 electron here. Then I become stabil. So in group 17, reactivity ini bergantung kepada the ability to receive electron. Kalau saya senang terima electron, if I can receive the electron easily, I am reactive. Kalau tak senang terima elektron, saya tak reaktif. Okay, and this is what we call electronegativity. Okay, electronegativity. The ability of the atom to receive electron. Got it? Everyone understand that concept? Okay, you think about it. You think about it. Which one you think can receive electron more easily? 2.7, 2.8.7, or 2.8.18.7? Same concept like the nucleus and uh, Wafia, nucleus and Suhashini, nucleus and Sharifah. What do you think?
2.8.18.7. No, the
Sorry?
last one lecture is easier to receive.
The last one, that means to say bromine. You say bromine easier to receive electron, is it?
Yeah.
Okay, class, how about the rest?
The first one.
Okay, who said the first one? Daniel. Okay, Lakshan also said the first one. Anyone else? Tak apa, salah tak apa. I'm just asking only. Okay, first one because it's nearer. Okay, Christina said bromine, the last one. Okay, 2.7, 2. Okay, some say, okay. So teacher give you the answer because don't want to waste time. Not much time, half an hour only left. Okay, so the answer is actually the nearer you are to the nucleus, the easier you are to receive electron. Okay, imagine me and Wafia. Wafia so close to teacher. One electron pass by. I can grab the electron and bring it to the nucleus. So therefore, I am able to attract the electron easily. Now, if it is Sharifah bromine all the way at the back there, she's so far away from me. Even if the electron want to go in, I have no way. My bond is so weak, I cannot go and grab that electron and allow it to come to me. Okay, so you need to take note that actually fluorine is the most reactive and bromine is the least reactive. Okay, and we are using the concept saya dah faham A again. Oh, but not saya dah faham A, saya dah faham dah. Okay, saya dah faham dah. Okay, what is the saya? S is size. Going down the group, the size of the atom increases. That one you all know, no problem. Okay, this slide they never put distance, but teacher want to put for you. Okay, so the distance between the nucleus and valence electron becomes further or nearer, class?
Further.
Very
Further.
good. It becomes further. You're going far away. What? When the size become bigger, you are further away from the nucleus. Therefore, the attraction, the forces, teacher cancel this. Teacher write forces of attraction between nucleus and valence electron becomes weaker. Correct. The further you are from me, you become weaker. Saya dah faham. Okay, now no more Saya dah faham dah. Okay, it is difficult when you're so far away from me. It's so difficult for the atom to receive one electron to achieve SOIE. Therefore, my reactivity will decrease. Okay, this one very jarang come out for exam. Jarang. Tapi kena tahu juga. They can ask in objective. So what you can do is you can take a picture. Okay, take a picture and then put into the class group. Okay, take a picture, put into the class group. All right. Okay, done. Okay, if it's done, teacher. Okay, thank you. Anis, Anis dah betul kan attendance Anis? Can you put in the class group who is absent with reason and who is absent without reason? Put in the camp group straight away. Boleh. Anis missing already.
Can teacher.
Okay. All right. So, what is the safety precaution here? Everything must be in the fume chamber. I told you it's poisonous, yeah? Okay, you must use safety goggles. Okay, teacher going to go a bit more faster. Two more things left only here. Okay, I've got period 3 and I have got transition element. Both also important. If you take out your periodic table that I gave you, okay, and you put it in front of you and you go to period 3, you will find all of this: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Okay, you will find all of this. Okay, and do you need to memorize? Yes, it is good if you can memorize. Okay, it's good if you can memorize. Teacher doesn't force you. If in paper 2 you will get it is in your periodic table. Okay, now 3 things that teacher want you to take note that you must know. I got something called a basic oxide. Number 2, I've got something called an amphoteric oxide. And lastly, I got something called an acidic oxide. You must know this: basic oxide, amphoteric oxide, and acidic oxide. Basic oxide always wujud in group 1 and group 2. Amphoteric oxide always wujud in group 14 to group 17. Amphoteric oxide always in group 13. Okay, this one you must know. Okay. So, based on what teacher taught you just now,
Go back, Aisha, please.
sorry,
Now, can you go back to the previous one?
same. What I'm teaching here is the same as the previous slide. Here, even better. I gave you straight away. So, basic oxide, actually, no need the word metal. The metal is actually just a way for you to know which one is it. A basic oxide in period 3 is group 1, group 2. Sodium, magnesium. Amphoteric oxide, group 13. Acidic oxide, group 14, group 15, group 16, group 17. That's it you need to know. So you remember Ba, not Baba black sheep, Ba. Okay? B is basic oxide. And if in the periodic table, always group 1 and group 2 appear first. After basic oxide is amphoteric oxide. Amphoteric oxide is group 13. So see how teacher arranged it? Group 1, group 2, group 13, and then I got acidic oxide. Acidic oxide, okay, is group 14 until group 17. Does that make sense to you?
Yes.
Okay. So what do we
Teacher,
want? Yeah.
so is boron also an amphoteric oxide?
Is boron in period 3?
Yeah. No, it's not in period 2.
So we're only doing boron. We're only doing period 3. Your level only doing period 3. We're not doing period 2.
Okay, je.
Thank you for asking.
What about group 18?
So group 18, because it doesn't, it's a stable octet electron arrangement. So normally it doesn't react with anybody. So we don't talk about it at all. Kan teacher taught you that day? Group 18 kan, it doesn't react with anything. It's so stable. It can live, but it's a noble gas. It's inert, doesn't need anybody. So we will never include them in this.
Teacher, what about argon?
Group 18 lah tu. A teacher just mentioned group 18. Group 18 is stable. So when it's stable, it will not react with anything. That's why teacher doesn't have to classify them. It's stable. So when it's stable, I don't donate, I don't receive, and I don't share electrons. So I don't need to be a basic, amphoteric, or acidic. Because what's happening now is all these elements, they will go and react with something. But group 18 cannot react with anything. That's why I don't classify them. So in order to understand what teacher is saying, see whether I have it here. Okay. So let me explain what I'm saying. Why does teacher say that group 1 is a basic oxide? Because when teacher put this basic oxide into an acid, I will get a reaction. When I put all this acidic oxide, I put it into a base or an alkaline, for example, sodium hydroxide. Teacher will get a reaction. And amphoteric means it can react with acid, it can also react with alkaline. So when teacher react with acid, I will get a reaction. When I react with alkaline, I will also get a reaction. That's why teacher call it amphoteric. Okay? So if a teacher take a group 18, let's say teacher take argon. If I take argon, it doesn't react with anything at all. So that's why teacher doesn't have to classify them at all. So must remember, a basic oxide only can react with acid. If a basic teacher react here with NaOH, class, will there be a reaction? Basic oxide plus NaOH. Will there be a reaction?
No, Chair.
No.
Very good. No reaction. Okay, I do another one with you. My acidic oxide here, down here, if teacher plus with acid, will there be a reaction?
No.
No, Chair.
No reaction. Very good. So you understand the concept already. When you do the question that teacher gave, you will understand what teacher is teaching you. Now you just get the concept only. Later we do questions. So you don't have to worry. Okay? Now, in period 3, all the proton number, they are increasing by 1. Correct or not? You check and see. Can you see sodium, the proton number is 11? All of you agree?
Yeah, Chair.
Yes.
Okay, magnesium, how much?
12.
24. Sorry. 12.
12. Aluminium?
13.
13,
Okay. Silicon?
14.
14,
Okay. 15 is what?
Phosphorus.
Okay. 16 is what?
Sulfur.
Sulfur.
sulfur,
17 is what?
Chlorine.
chlorine,
18 is what?
Argon.
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 Okay. Very good. Okay. Now, Iskandar, Iskandar, Hari, and Daniel cannot answer. I want the rest to answer. What's my electron arrangement for each of them? What is teacher's electron arrangement for sodium?
281,
Wait, who answered? Oh, Sachin. Okay, good. 2.8.1. Okay. Sachin cannot answer already, yeah? What's my electron arrangement for magnesium? Very good. 2.8.2. Anis and Lakshan cannot answer. Adnin cannot answer. So, aluminium? Okay, Hayden and Christina cannot answer. 2.8.3. Next, silicon? Zirale and Putri 2.8.4. Putri betul ke 2.4.4? Alright, Putri, good job. Okay, phosphorus. The rest cannot answer already. Yang dah jawab, tak boleh jawab. Cikgu nak orang lain. Dah tak ada orang lain dah. The rest sleeping already. Okay, Farel. 2.8.5. Okay, Farel and Kavi still awake. Oh, okay. 2.8.5. Alright. Okay, sulfur? Alright. 2.8.6. Chlorine. Okay, semua boleh jawab. 2.8.7. Okay, no. Jangan semua jawab. Okay, because I just realized some of you haven't jawab yet. Sorry. Argan, okay, yang never got a chance to answer yet. Tolong jawab. Lakshan. I said yang never got a chance yet. Anyone didn't get a chance yet or not? So everyone got a chance. Okay, never mind. Lakshan already third jawab. Never mind. Okay, so the answer is 2.8.8. This is very happy. All of y'all tried to answer. Thank you. Okay, what is the similarities that you see in from 2.8.1 to 2.8.8? What is the similarity you saw there?
Proton number increased by 1.
Okay, proton number is increasing by 1. That's not a similarity though. Okay, what is a
2.8.
similarity?
Got
The
3
first
shells.
Very good. Okay, they have 3 shells filled with electron. Who said that?
Daniel je.
Okay, they have 3 shells. Good job, Daniel. They have 3 shells filled with electrons. Say 2.8.1, all of them are going into 3 shells. Okay, all of them here, they are going into 3 shells, and that's very important. Okay, and everything here, they are solid except for chlorine and argon. These two, they are gases. Okay, this is something that you must take note. Yeah, going across the period, okay, you see that the size of the atom actually becomes smaller. Okay, and then I don't this particular slide doesn't have a very good explanation, so I want you to write down my explanation. Why is the size of the atom becoming smaller? When you look at group 1, group 17, group 18, the size is becoming bigger. But why going across period 3, the size is becoming smaller? So point number 1, okay, the number of protons, okay, the number of protons increases going across period 3. All of you agree? Can you see the number of proton is increasing? 11, 12, 13, 14, 15. Can you see that?
Yes.
Yes, yeah.
Okay. When number of proton is increasing, number of proton can. Okay, number of protons, normally we don't say protons. Okay, number of proton. You put protons, also nobody's gonna to penalize you, it's okay. So when my number of proton is increasing, okay, therefore, the force of attraction between the nucleus and valence electron becomes stronger. Okay, the force of attraction between the nucleus and the valence electron becomes stronger going across period 3. Okay, going across period 3. Okay, and point number 3,
must we put
electrons.
going across the period?
Yeah, for now, yes lah. For today's lesson, yes. Electrons are pulled closer to the nucleus. Therefore, size becomes smaller. Okay, so teacher give you an example. For example, you drink 11 cups of Milo and 17 cups of Milo. Your 11 cups of Milo is your sodium, and your 17 cups of Milo is your chlorine. So going across period 3, you got 11 cups of Milo and your 17 cups of Milo. Valence electron becomes what? What, darling? Point 2 is
The
forces of attraction between nucleus and valence electron becomes stronger going across period 3.
the third one, Chef?
So bad am I writing? Oh my gosh.
Sorry, Chef.
Does that makes the smaller the size of atom? Yes, correct. So I'm trying to explain now, Umaira, kejap, Okay. then you will understand better. Okay, so the third one is electrons are pulled closer towards the nucleus. Okay, the electrons are pulled closer towards the nucleus, therefore size is smaller. Actually, not the way you're saying it, Umaira. You're saying smaller the size, the stronger the FOA. Actually, terbalik. It's the stronger the FOA, the smaller the size. So let me explain. I got 11 cups of Milo. I got 17 cups of Milo. The cups of Milo here represents my number of proton. So the more number of proton I have, the more stronger I am. So when I am stronger, let's say teacher's the nucleus, I'm stronger. I got 11 cups of Milo. I don't have a very strong force of attraction between the nucleus and valence electron. But if I've got 17 cups of Milo, I've got a stronger force of attraction between my nucleus and my valence electron. Okay? So when let's say I drink 17 cups of Milo, okay lah, I will get diabetes lah. And I'll get instant diabetes. Tapi I become stronger. So when I got 17 cups of Milo, I can pull, I've got a lot of strength. So I am able to pull all the electrons closer towards the nucleus. And when I'm able to put the electrons closer towards the nucleus, that's why the size is smaller. Compared to 11 cups of Milo. If I've got 11 cups of Milo, my strength to pull the electrons closer to the nucleus is lesser. So the electrons don't come so close to the nucleus. So the size is still very big. So that's why going across the period, okay, point number one, my number of proton increases. And when the number of proton increases, the forces of attraction between nucleus and valence electron become stronger. Okay, therefore electrons are pulled closer towards the nucleus, therefore size becomes smaller. So, how teacher wants you all to remember? P, F, E. Okay, P, F, E. What is P?
Proton.
Okay, the number of proton increases. What is F?
Force of
forces
attraction.
of attraction.
Force of attraction becomes stronger. You remember Milo. Remember Panchina loves Milo. She got 11 cups of Milo. She got 17 cups of Milo. When she got 17 cups of Milo, Panchina is stronger. When she got 11 cups of Milo, she's weaker. When she drank 17 cups of Milo, she was loved us so much, she will pull us closer towards her. Think like that. Can think like that or not? Correct. Very good, Daniel. When you got a stronger force of attraction, then the size becomes smaller. Like how I said lah. When Puan China is drinking 17 cups of Milo, I become stronger. I pull all of you, my darlings, closer towards me. And then all of you come closer towards teacher, the size becomes smaller. Understand?
Yes, sure.
So P, F, and E. All of you writing down P, F, E. Proton, force of attraction. Electrons are pulled closer towards the nucleus. That's why your size is smaller. If anybody want to take a picture, quickly take a picture. Because now the size will attract the electronegativity. Cikgu baru ajar tadi electronegativity. What is electronegativity?
The ability
absorb.
to receive
Taking in
electron.
Correct.
Taking in.
Yes, ability of the atom to take in, or take in is not a good term lah. Ability of the atom to accept or to receive electrons. Okay, now why going across the period, the electronegativity is increasing? Why? Number one, because my size is already smaller. Okay, when my size is smaller, is the nucleus and the valence electron close to each another?
Yes.
Yes.
Okay, so the force of attraction between my nucleus and my valence electron is closer to each another. My force becomes stronger. So my force becomes stronger. The nucleus can attract electrons easily into the atom. Can you understand that? So here, just now, if size, teacher want you to remember PFE. For electronegativity, teacher want you to remember SFE. Okay, just now was proton. PFE, now SFE. Who here your name starts with P? Pranat kan? Okay, Pranat FE. Then who here your name starts with S? Sachin. Sachin FE. What is something that we can use with F and E? What is a nice
Enemies.
no lah? F and E, what can you see? F and E.
E for enemies.
Okay. If someone can think of something, then you go ahead, okay? Pranat, friends with anybody here, your name starts with E.
Edward.
Okay. Can. Edward is good. Okay. So Pranat, Pranat falls in love with Edward. Sachin falls in love with Edward. Okay, can. Perfect. Okay, so the first one is Pranat fall forever with Edward. And then the other one, Sachin forever with Edward. All right. Can someone quickly write this down, please? Or put it in the group so that we will never forget it. Sachin forever with Edward and Pranat. Boys, I hope you all don't mind. Huh? This is just an easy way to remember, okay?
I can already never forget it.
Always. All right. Okay. Never mind. Once in a while can betray with one Shina's permission can. Okay, take a picture and put in the group. Teacher got a bit more to finish only. A bit more only. Okay. So always mine. What is always yours, Prana? Who is always yours? Edward's always yours, is it? Sachin's always yours. Okay, okay. Okay, don't tell me. I don't want to know. Ignorance is bliss. I don't know what's going on is better. Okay. Now, semi-metals in group in period 3, I've got a semi-metal there. What is a semi-metal that you can see? What's a semi-metal that Pranat forever in love? Forever in love? Did I say forever in? Oh, okay. Okay, semi-metal. Okay, so you got sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Which one here you think is my semi-metal?
Silicon.
Very good. It is the silicon. You must know this. Can come out in KBAT. Okay. Now, where do I use all these silicons? I use it in diodes and transistors, anything in computer, mobile phone, televisions, and video recorders. Okay. So that is group period 3. Teacher got 10 more minutes. I've got a few more slides only this more left, a bit more only. Okay. And then over the weekend, over these holidays, the paper that Anis took for your page 1 until page 27, teacher wants you all to try. If you can do that question, it's already very good. You're ready already. Okay, so teacher quickly finish. Transition element, if you look at your periodic table teacher gave you, is anything from group 3 through group 12. Anything that you can see there, scandium. You've got scandium, you've got zinc, you've got cobalt, you've got manganese, you've got titanium, everything that you can see there, they are called transition elements, not transition metals. Some students say, teacher, transition metals, no such thing. Transition elements. Okay, all transition elements, they are shiny, they are ductile, they are malleable, they have high tensile strength, they are high melting and boiling point. Very good to remember. Okay, because they are metal, so they always will have this property of a metal. They've got high density. Of course, they are metal. They can conduct heat and electricity. Okay, what's so special about transition
Teacher,
element?
what's the meaning of ductile?
Okay, how many of you watch Fantastic Four? There's this one guy that could stretch out his hand, stretch and stretch and stretch forever, right?
Yep.
I forgot what's his name. Okay, that's
Second
called
person.
ductile. Can stretch. Okay, malleable means I can shape it to any way I want. I take a metal and I hit it one side, it bends. Then I hit another way, it will follow. So it can follow the direction that I want it to bend into. Okay, let's say I put Adrian in front of me here. And I take a hammer and I hit him in the front. He'll move backward. I hit at the back, he'll move forward. I hit down, he'll move upward. Okay, I hit down, I hit down, he'll move downward. Okay, that's the meaning of malleable. Okay, able to shape it, able to bend it. Okay, Mr. Fantastic. Okay, yes, correct. Can't remember last, but I love watching these kinds of movies. Okay, transition element, they are very, very important. I've got actually 4 special characteristics of a transition element, very important. Remember just now teacher taught you iron 2 iron, iron 3 iron. Only a transition element can show me different oxidation number. Okay, iron 2 iron, iron 3 iron. Even like copper, somebody asked me that day, teacher, how I know not copper 1, why is it copper 2? So it's because it's a transition element, that's why I've got different oxidation number. And I can form colored ion or form colored compound. Must have the word form colored ions or form colored compounds. Like I told you just now, iron 2 iron, you drew the tree for me. What color is iron 2 iron?
What you? Oh,
Green. Okay, what color is yes, Lakshan already know my next question. It is brown. Okay, what color is copper to ions?
Green.
No.
Brown.
No.
Purple.
Purple.
No.
Red.
Yellow.
Okay, someone said it blue. Okay, yellow is chromate. Okay, so chromate ions is yellow, dichromate is orange. Okay, so you will learn all this. Okay, only transition elements have different colors, so it's very nice and it's very useful as a catalyst. When teacher want to make ammonia, my catalyst is iron, a transition element. When teacher want to make nitric acid, my catalyst is platinum, transition element. Okay. When teacher wants to make copper 2 got, we normally don't talk about the color. Only, sorry, copper 1 got, we don't talk about the color. Copper 2, only we mention the color because copper 1 you all don't learn. Copper 2, iron 2, iron 3 you all learn. Okay. When teacher want to make sulfuric acid, my catalyst is vanadium 5 oxide. When I want to make margarine, I use nickel as my um, catalyst. And that's it. Well done. With all the hiccups we had today and teacher don't know how to use this, don't know how to use that, we still managed to finish before time. Okay, I'm very, very happy with it. Wait. Let me stop presenting. Okay. I will send a quizzes. Teacher will send a quizzes. Why Pranat left so fast? Teacher didn't finish also yet. Teacher will send a quizzes to you all so you can try the question. Pickle? What pickle, Lakshan? Lakshan hungry already. Must be want to eat his dinner already very soon. Okay. Can we take one class photo? Wait, number 1, finish the paper teacher gave you. Not the module, not the purple book, but the paper. Try to do that. Number 1. Number 2, I will send you my slides. Oh, but spelling wrong also for the nickel here, Pranat. But yeah, nickel, not pickle. Okay. I'll send you the slides and I'll send you a quizzes. Y'all try and do the quizzes, okay? And that's it. Correct. Thank you, Pranat. Okay, and that's all for today. Teacher would like to take a picture, if it's okay with y'all. Okay, if you can turn on your cameras, please turn on your cameras. If you don't want to, cannot force you. Can I request one person helping teacher to take the photo? It doesn't matter. If you want it on, you can turn on the camera. If you don't want, it's okay. Teacher don't mind. Okay, nobody wants to turn it on. It's okay. Anyone who's happy to take a picture for teacher? Oh, thank you, Myra. Very nice. It's the first time that I have actually a girl happy to turn on the camera. Thank you. Camera not working, Sachin? I don't think so lah.
No,
Okay,
no, sir. It's
Anis also,
actually
thank you,
working, but I don't want to
Anis.
turn it on.
Sure not, Sachin.
Sure. My camera working, sir.
Okay, doesn't matter. Okay, thank you, Daniel, as well. Mana Anis tadi? Anis ran away already. Okay, so we do a quick photo. Okay, so let's not waste time. Any volunteers to take the photo? Shh. Hi, Pranat. Okay, thank you. Alamak, Pranat turned off the cameras. All run away already. Okay. Never mind lah. Let this teacher take the photo. Nila, no one wants to help me. Okay. Oh, Daniel taking the photo? Daniel, are you using the phone? Are you using the?
Kita using a laptop.
Yeah, can you take your phone and use it?
Alright, je.
Okay. All right. All smile at Daniel, even though you didn't turn on your camera. For the sake of smiling, ah. Daniel, say when, okay?
One, two, three. Okay, done je.
Okay. Thank you, class. I hope you learned something today.
Thanks, sir.
Thank you,
Welcome.
teacher.
Thank
you,
you
teacher.
for coming. Actually,
Bye,
so
sir.
good of y'all to come
I learned
online.
a lot
We're so
yesterday.
proud of y'all. I'm actually very happy with each one of you. Anis, where are you, Anis?
Picnic.
Where are you? Welcome.
Saya ke teacher? Teacher tahu saya ke?
Anis kat mana?
Saya kat kampung.
Oh my gosh, thank you for joining at the kampung as well.
Not welcome.
Bye-bye,
So are you
sir.
under the tree or something?
No, under the tent. My
Under
father
the
did the tent.
Okay, all right. Okay. Thank you so much for joining, all of you.
Okay,
Bye-bye.
teacher. Bye. Thank you.
Take care.
Thank you,
Bye
teacher. Goodbye, teacher.
bye. Bye.
Have a nice day.
You too, Iskandar. Study my chemistry, Iskandar. Iskandar left already. Bye bye. Hayden, you are late. Got punishment for you. Why you late, Hayden? You came home late from where? You never tell me earlier on. So got punishment. Teacher's going to put makeup for you, okay? Wafia, okay. Sharifa, okay. Adrin, sorry. Oh my goodness, I am recording. I forgot. Let me off it.